Welcome back to Speller Tutorial Services. In today's video, we're going to use the completing the square to solve a quadratic equation that has complex or imaginary roots, and that just means that it has a real number part and an imaginary number part for it to be complex or imaginary. All right, let's begin with a rewrite where we have 5x squared plus 2x plus 3 is equal to 0. I want to change this left hand side into a perfect square trinomial, so let's move this 3 out of the way. In doing so, I end up with 5x squared plus 2x. These resolve to 0 is equal to -3. And then I also see that I want to get rid of this coefficient of a 5 in front of the x squared term. So that means I'm going to divide each one of these terms by 5. Alright, in doing so, this first term here, these 5's cancel, leaving me with x squared plus 2/5 x is equal to a -3/5. Now I need to figure out what number to add to both the left hand side and the right hand side to make this left hand side a perfect square trinomial. We begin by taking the coefficient in front of the x term, which is 2/5, and I'm going to divide that 2/5 by 2. And really that's the same as 2 over 1, and I'm going to square that result. Now I've just created a complex fraction. Whenever I have a complex fraction, I know that division turns into multiplication, and then I end up writing the reciprocal or just flipping the denominator. In this case it was 2 over 1, now it becomes 1/2. Once I get to this point, I see that I can cross cancel, so these 2's cancel, and now I'm left with 1/5 squared. And I know that 1/5 squared is actually 1/25. So I'm going to end up adding 1/25 to both the left hand side and the right hand side. In doing that, the left hand side becomes the perfect square trinomial, which is going to be x plus 1/5, and that whole quantity is squared. And then on the right hand side, I'm going to have -3/5 plus 1/25. Let's focus on this right hand side. Before I can add these two fractions here, they must have common denominator, and I see that for 3/5, if I multiply both the numerator and denominator by 5, I end up with 15/25, and again it's also going to be negative because that's what I'm starting with. So here I have -15/25 minus 1/25, and I rewrite the left hand side. Alright, now I'm going to continue up here. When I evaluate, I'm going to have x plus 1, the quantity x plus 1/5 squared is equal to, well, I have a, and really that should be positive, I have a -15 plus 1 to give me a -14, and my denominator stays at 25. And now to solve for x, I notice my left hand side is squared, so I need to take the square root of both sides of this equation. Now I'm left with x plus 1/5 is equal to -√14 over, oops, I'm sorry, let me fix that, that's not correct. I'm left with the square root of -14 over 5, because the square root of 25 is 5. Now what I need to do to get the x by itself, I subtract 1/5 from both sides. These 1/5's cancel, and I'm left with x is equal to -1/5 plus or minus, well, the square root of -14 is really I√14, and the denominator is 5. And I see I can write this in a more compact way as -1 plus or minus I√14 all over 5. So this here is the complex or imaginary root for this quadratic equation. That sums it up for this video by Speller Tutorial Services. Please friend us on Facebook and also subscribe to our YouTube channel, both found under the same name. And as always, thank you again for watching.